Hello. In continuation of noble gas elements, one other very important process is separation of noble gases from each other. Separation of noble gases from air is chemical method. We are using their chemistry. Here we are going to depend on a physical technique that is called adsorption. What is adsorption? What are the principles? How it is going to be done? See here. Explain Dewar's method. Physical method, Dewar's method for the separation of noble gases. Dewar's method depends on a physical phenomena, adsorption. Adsorption is the attraction and accumulation of gaseous molecules on the surface of solids or liquids is called adsorption. It is a physical phenomena in which the gaseous molecules are generally attracted and accumulated on the surface of the solid. It is adsorption. Here three important lines are there. You can say principles for noble gases. First point is helium. Except helium, all the noble gases can be adsorbed over activated charcoal. So helium, whatever the temperature, whatever the condition, it is not adsorbed. Happy for helium. Second point, adsorption of noble gases on the charcoal increases with increase in atomic weight due to increase in van der Waals forces. When the molecular mass is more, the van der Waals forces will be more. When the van der Waals forces are more, it will be easily accumulated. So the adsorption process will be increasing down the group. Adsorption depends on the temperature. Lower atomic weight are adsorbed at lower temperatures and higher atomic weight gases are absorbed at higher temperatures. So for lower atomic mass gases like neon and argon, a lower temperature is required. For xenon and krypton type gases, a higher temperature is required. You can see here the apparatus. This is the Dewar's flask. Noble gas mixture inlet one side and noble gas mixture outlet. Unadsorbed gases we are saying there. And here liquid air, coconut charcoal. This overall is called Dewar's flask. So the charcoal is maintained at different temperatures based on the liquid air. Dewar's flask. It is a double-walled flask containing activated coconut charcoal in the middle. A tube is arranged above the flask to introduce the gaseous mixture and to remove the unadsorbed gases. The procedure involves the following steps. Step 1. The mixture of noble gases is brought in contact with charcoal kept in a Dewar's flask maintained at a temperature of 173 kelvins. Argon, krypton and xenon gases get adsorbed while helium and neon remain unadsorbed and are pumped out. So first Dewar's flask we are taking at 173 Kelvin. Argon, krypton, xenon, they are comfortable with this and helium and neon are not comfortable. It is like when you are going to a hill station type of places, you and your friends went. Helium is one of your friend. Helium is not at all having any intention to stay in any hotel. He wanted to sleep in his own car and remaining based on your budget you want to go to your different hotels. First you went to a grand hotel where the charges are very high. So neon said no, it's not for me. Of course helium is always with neon because helium is never trying to take a hotel. So helium and neon are going out, but argon, krypton, xenon, 10,000 rupees, 10,000 bucks for them is not a matter. So argon, krypton, xenon stayed in that hotel like that. 173 Kelvin temperature is okay for argon, krypton, xenon. So they stayed there. Helium and neon are out. You can see here the table. Noble gas mixture at 173 Kelvin. Adsorbed gases argon, krypton, xenon. Unadsorbed gases helium and neon. This is step 1. In step 2, the mixture of helium and neon introduced into another flask containing charcoal maintained at a temperature of 93 kelvins. Only neon gets adsorbed, leaving behind helium, which is pumped out. This charcoal is warmed to recovered neon. Now you see, neon and helium, they are taken into another charcoal. You can say another hotel where the charges are considerably low. So neon said, okay, this is okay for me, but helium not having any intention, helium out. Neon is staying there and you can remove the neon by just warming the charcoal because when you are increasing the temperature neon cannot stay there, so it simply comes out. So second condition, 93 kelvins, neon helium can be separated. Now we have 173 Kelvin, argon, krypton, xenon. Step 3. The first charcoal with argon, krypton, xenon adsorbed on it is brought in contact with another charcoal kept at 77 Kelvin. Argon, being a lighter gas, diffuses into this charcoal 77 Kelvin and is recovered by warming repeatedly. So what we are going to do here is argon, krypton, xenon that is connected with another coconut charcoal at 77 Kelvin. Argon being lighter gas, so 77 means it's simply moving into the 77. Then you are heating the 77 Kelvin charcoal, argon is out. So in the first charcoal, still there are krypton and xenon that is heated to 183 Kelvin. Step 4, krypton, xenon remain in the first coconut charcoal. When this charcoal is heated to 183 Kelvin, krypton releases, xenon still there, and again on heating it can also be collected. You can see here noble gas mixture, 173 charcoal, argon, krypton, xenon adsorbed, helium, neon unadsorbed, helium, neon 93 Kelvin charcoal, neon adsorbed on warming separated, helium unadsorbed separated, argon, krypton, xenon that is kept in contact with another charcoal at 77 Kelvin, argon diffuses to 77, on heating again recovered, krypton and xenon heating to 183 Kelvin, krypton recovered, argon still there, and again further heating it is also coming out. So in this way you can separate the noble gases from noble gas mixture. Two important lines here. It is depending on a physical process, adsorption. Helium is not having any intention to get adsorbed on the activated coconut